Hello student, this is Darasa Online. My name is Edgar Mshana. I'm teaching advanced mathematics. Today we are going to discuss some review questions on coordinate geometry 1. And the subtopic that we are going to review their questions is called the rectangular Cartesian coordinates. And the parts that are in rectangular Cartesian coordinates that we are going to discuss are with the perpendicular distance from a point to a line. But again, we have the area of a triangle. And the last part will be area of a rectangle. Dear student, join with me till the end of this presentation. Welcome. Now, my dear student, let us start with the perpendicular distance from a point to a line. Now, here we have a line named as AX plus BY plus C is equal to 0. This is our line, and that is the name of our line. But again, we have another line which makes a right angle to this line. This line is called PB. That we are going to find its distance. So our interest here is to find the distance PB. So this line makes a right angle with this line. Now, what is the general formula that we are going to use to find the perpendicular distance? The general formula is here. So to find that perpendicular distance, which is PB, is called D. So D is equal to the absolute of AX plus BY plus C over the square root of A squared plus B squared. So that is how to find the perpendicular distance. Now, my dear student, let us see how this formula is very useful to some of the questions. And here we have the review questions. We are going to start with A. The question says, find the shortest distance from point P, that is 2, -3, to the line 4x minus 3y plus 3 is equal to 0. That is your question. So in this question, in the review question 1A, that is 1A, we've given the point, that is point P. So point P is 2, -3. But again, we have a line. That line is named as 4x minus 3y plus 3 is equal to 0. So our interest is to find the shortest distance. So remember, our general formula to find the distance is D is equal to absolute of AX plus BY plus C over the square root of A squared plus B squared. Again, that is absolute. My dear student, why are we using the absolute? That is to avoid a negative answer. Always distance or length is always positive. So we are using absolute to avoid a negative. So our distance will be equals to, so remember AX plus BY plus C is the equation we have been given. So that is the absolute of 4x minus 3y plus 3 over the square root of, now you can see here A, that is 4 squared, plus our B is -3, again squared. Okay? But in this equation, we have to substitute the given coordinate, that is coordinate P. So D will be equals to absolute of, remember we have values of x, that is value of x and value of y. So just substitute direct in our equation. So we are going to have 4 times 2 minus 3 times the value of y, which is -3, then plus 3. So this one over the square root of, now remember here we have 4 squared, which is equal to 16. Then plus, we have -3 squared, that is 9. So the perpendicular distance will be equals to So here we have 4 times 2. That is 80. Then we have negative 3 times negative 3. That is positive 9. Then plus 3 over, this time we have 16 plus 9, which is equal to 25. So D will be equals to, so we have 8 plus 9, that is 17. So 17 plus 3, that is 20. So we have 20 over, so again we have the square root of 25, which is equal to 5. So this will be equals to, we just take 20 divided by 5, which is equal to absolute value of 4, which actually is equal to 4. So 4, that is the distance. So it will be units of length. That's the units of length. So that is how to find the shortest distance for our question. My dear student, let us proceed with the second review question, that is 1b. So the question says, if the perpendicular distance of the point 1, 1 from the straight line 3x plus 4y is equal to h is 0.2 units, find the possible values of h. This time we have unknown. So this is unknown, h is unknown. So we are looking for values, the possible values of h. So again, for such kind of a question, we have been given the coordinate. So the coordinate here is 1, 1. So that is our coordinate. So our coordinate, that is 1, 1. But again, we have the equation. So the equation, that is, we have 3x plus 4y is equal to h. But again, we have the perpendicular distance, that is, the distance is 0.2. So here D is equal to 0.2. So again, we use our general formula of finding the perpendicular distance. So in this case, our equation, it is 3x plus 4y is equal to h. So let us make arrangement of this equation. So arrangement of this equation can be written as 3x plus 4y minus h is equal to 0. So we just substitute this equation in our general formula. So we are going to have 3x plus 4y minus h over the square root of, remember here we have a squared plus b squared. So that is 3 squared plus 4 squared. So this will be equals to, so remember, at this stage we substitute values of x and y. So values of x and y is this coordinate. We have a coordinate which is 1, 1. Therefore, we are going to have the absolute of 3 times 1 plus 4 times 1, then minus h over the square root of, remember here we have 3 squared, which is equal to 9. Then plus, again we have 4 squared, that is 16. Now in this case, we are going to have the following. That is D is equal to, we have 3 times 1, that is 3. Then plus, again we have 4 times 1, that is equal to 4. Then minus h over, so again here we have, that is 9 plus 16. That is the same as the square root of 25. So now this will be equals to, here we're going to have 7 minus h over, now we have the square root of 25, which is equal to 5. But remember, we have been given the value of d. So d is equal to 0.2. So we can substitute the value of d. So that is 0.2, which can also be written as 2 over 10 is equal to, now we are going to remove the absolute value. How are we removing the absolute value? We introduce the plus and minus followed by a bracket of 7 minus h over 5. That is how are we removing the absolute value. So here we are going to have, that is by 2 is 1, by 2 is 5. We have 1 over 5 is equal to plus or minus. We have 7 minus h over 5. So case 1, we are going to start with positive. That is case 1. Case number 1, we are going to start with 1 over 5 is equal to plus 7 minus h over 5. So dear student, on simplifying here, we are going to remain with 1 is equal to, that is 7 minus h. So now h will be equal to 7 minus 1. Therefore h is equal to 60. That is for the case of positive. Let us proceed with the second case, that is for negative. That is case 2. This time we take the negative. So that is 1 over 5 is equal to minus 7 minus h over 5. That is the second case. So again here we open up the bracket. We are going to have 1 over 5 is equal to, so here we have negative times 7, we have negative 7. But again, we have negative times negative h, that is positive h over 5. So again, my dear student, here we can simplify 5. So we are going to have 1 is equal to negative 7 plus h. So again, the possible value of h will be equals to 1 plus 7. So h is equal to 8. Now we have two values of h. So here we just say the possible values of h are, remember the first value, we have 6, that is 6. And the second possible value of h, that is 8. So those are the possible values of h. And that was a review question B, 1B. So let us proceed with C. We have C here. Determine the ratio in which the line 3x plus y minus 9 is equal to 0 divides the line segment joining points 1,3 and 2,7. So again, that one is the application of the distance formula or perpendicular distance. Let us see how we can do that question. So given we have the line that is represented by the equation 3x plus y minus 9 is equal to 0. But again, we have two coordinates. The first coordinate is 1,3, while the second coordinate is 2,7. So the interest of this equation is to determine the ratio. in which this line divides the two coordinates. So from our general formula, that is d is equal to ax plus by plus c over the square root of a squared plus b squared. That is our general formula. So we are going to start with the first coordinate. So say using coordinate 1, that is 1, 3. And of course here we can use d1 because we are going to have the second coordinate, that will be d2. So say d1 is equal to the absolute of, so our equation is 3x plus y minus 9 over the square root of course we have 3 squared plus 1 squared. Now here we substitute this coordinate. So the distance will be equals to 3 times 1, that is the value of x. But again plus, we have the value of y, which is 3, then minus 9 over the square root of, remember here we have 3 squared, which is equal to 9, plus, again we have 1 squared, that is 1. Therefore d1 is equal to, here we have 3 times 1, because this is 3, then plus, the second one is 3, that is 3, then minus 9 over, so here we have 9 plus 1, so we have the square root of 10. This is the square root of 10. Therefore, d1 will be equals to, here we have, that is 6 minus 9 over square root of 10. So student, in this case, d1 will be equals to absolute of negative 3 over the square root of 10. But remember, we are using the absolute to avoid negative. So d1 will be equals to 3 over square root of 10, because the absolute of negative 3 over square root of 10 will be positive, that is 3 over square root of 10. So again, let us proceed with the second coordinate. So this time, say using the second coordinate, that is 2, 7. So this time we use d2. So we say d2 is equal to the absolute of, remember we are using the same equation, which is 3x plus y minus 9 over the square root of 3 squared plus 1 squared. But this time we substitute the second coordinate, which is 2, 7. So we are going to have d2 is equal to absolute of, we have 3 times 2 plus, of course, followed by y. So the value of y is 7. So plus 7, then minus 9. That is 9 over. Remember here we have 3 squared. That is 9. Then plus, we have 1 squared. That is 1. Therefore, d2 will be equals to, we have 3 times 2, that is 6. Then plus 7 minus 9 over, we have 9 plus 1, that is 10. So we have the square root of 10. So we have 6 plus 7, that is 13, minus 9, we are going to have the absolute of 4 over the square root of 10. But the absolute value of 4 over square root of 10 that is equal to 4 over the square root of 10. Now we have D2. So here D2 is equal to 4 over the square root of 10. But our interest is to determine the ratio. The ratio which divide the two coordinates by using this equation. So here we just take D1 ratio D2, which is equal to, remember the value of D1. D1 you have 3 over square root of 10. So we have 3 over square root of 10 ratio D2. D2 it is this one, that is 4 over the square root of 10. Now let us simplify this equation to see the final answer. So remember, in ratios, this one can be written as D1 over D2, which is equal to 3 over square root of 10 over, be the same, that is 4 over square root of 10. Or this one can be also written as D1 over D2 is equal to 3 over square root of 10 times square root of 10 over 4. So in this case, we are going to have D1 over D2 is equal to 3 over 4. Now in ratios, this also can be written as D1 ratio D2 is equal to 3 ratio 4. Now this is the required ratio. Therefore, here we say the ratio, that is the ratio which divides the line 3x plus y minus 9 is equal to 0 is 3 ratio 4. So that is another way where we can apply the distance formula, that is to determine the ratio. So my dear student, we continue with the area of a triangle in XY plane. So we have a right angled triangle here that is have coordinate A x1, y1. But again, the second coordinate, that is B, x2, y2, and the last coordinate, that is C, x3, y3. Now suppose you are supposed to find the area of this triangle. Now, in coordinate geometry, there are a special formula that is going to help us to find the area of that triangle. So the area is equal to a half. Then we use the determinant approach to find the area or to calculate the area. So the determinant approach, we start with the first coordinate, that is x1, y1. We proceed with the x2, y2, that is the second coordinate. The third coordinate, that is x3, y3, but we repeat the first coordinate, that is x1, y1. So that is the general formula that is going to help us to compute the area of a triangle. Now, my dear student, let us see the review question, that is to find the area of a triangle. So here we have a review question which says find the area of a triangle formed by joining the points A, that is 2, 3. We have B, 5, 7, and C, -3, 4. So we have 3 coordinates that we are going to use them to find the area. So remember, we have the general formula, that is area is equal to a half determinant of x1, y1, x2, y2, x3, y3, then we'll repeat x1, y1. So here we are going to use the arrow and dotted arrow. So first case we start with the arrow. So we just take x1 times y2. Then we proceed with x2 times y3. Then we take x3 times y1. So again, we use dotted arrow, that is y1 times x2. We proceed with y2 times x3. And the last one will be y3 times x1. Therefore, the area of a triangle, that is A, will be equals to a half. Then we use the bracket. We start with the arrows. That is x1 times y2. This one plus. We proceed with x2 times y3. That is x2 times y3. Then x3 times y1. So this one we minus the dotted arrow. That is y1 times x2. So we have y1 times x2. Then plus, we have y2 x3. That is y2 x3. And the last one is y3 x1. That is y3 x1. So, my dear student, that is how to find the area of a triangle. So, back to our question, we'll follow the same procedure. So, the coordinate in our question, we have A, coordinate A, that is 2, 3. But the second coordinate, that is B, we have 5, 7. And the last coordinate, that is C, we have -3, -3, 4. So, my dear student, you can label these coordinates to avoid confusion. So, remember we have x1 and y1, followed by x2 and y2. And the last one is x3, y3. So we just substitute in our general formula. So we are going to have the area now, that is A, will be equals to a half determinant of, then remember we start with x1, y1. So x1, y1, we have 2 and 3. And the second one we have x2, y2. That is 5 and 7. And another one we have x3, y3. That is -3 and 4. And the last one is x1, y1. That means we'll repeat the first coordinate. So the first coordinate is 2 and 3. So remember, we use arrows and the dotted arrow. So this one will be 2 and 7. But again, 5 and 4. And also we have 3, negative 3 and 3. For the case of dotted arrow, this one will be 3 and 5. That is 3 and 5. Followed by, we have 7 and negative 3. The last one is 4 and 2. That is 4 and 2. Now, let us see how are we going to get the area of this triangle. So remember, area, that is A, is equal to a half. So bracket of, starting with red arrows, that is 2 times 7. So we have 2 times 7, followed by, we have 5 times 4. That is 5 times 4 plus, the last one we have negative 3 times 3. That is negative 3 times 3. But this one, we minus, so this time it will be dotted arrows. So for the case of a dotted arrow, we have 3 and 5. 3 times 5, that's 3 times 5. Then plus, the second dotted arrow, we have 7 times negative 3. That is 7 times negative 3. Then the last dotted arrow is 4 times 2. So we have 4 times 2. So now it's just a matter of multiplication and adding to get the final answer. So area will be equals to a half, bracket of, remember here we have 2 times 7, that is 14, plus, followed by 5 times 4, that is 20. Now this one is negative 3 times 3, so it will be minus 9. So this one minus, we have 3 times 5, that is 15. Then that will be minus, because you have 7 times negative 3, that is 21. The last one will be 80. So here we have a half, bracket of, here we have 14 plus 20, that is 34, minus 9. So this one minus, then we have 15 plus 80, that is 23, minus 21. So we are going to have a half, bracket of, we have 34 minus 9, that is 25. So here we have 25. So 25 minus, we have 23 minus 2, that is 21. Sorry, that is 23 minus 21. So we are going to have 2, that is 2. So this is equal to a half, bracket of, or just times, we have 25 minus 2, which is equal to 23. So here we have 23. So it's the same as 23 over 2, or just 23 divided by 2, which is going to be 11.5. Remember, we are looking for area of a triangle. So this one, the SI unit is squared, units. Therefore, our area, that is area of our triangle, will be equals to 11.5 squared units. So that is how to find the area of a triangle when we have 3 coordinates, something which is very simple. So again, my dear student, let us proceed with the area of a rectangle. This time we are going to discuss about the area of a rectangle. So here we have a rectangle drawn in XY plane. So this rectangle has 4 coordinates. Coordinate A, that is x1, y1. But the second coordinate, that is B, x2, y2. And the third coordinate, that is C, x3, y3. And the last coordinate, that is D, x4, y4. Even that one is possible to find its area, and it is very simple. Let us see the general formula for finding the area of a rectangle. Here we are going to use the determinant approach to find the area of a rectangle. This time again we start with the first coordinate, that is x1, y1, followed by the second coordinate, that is x2, y2, and third coordinate, that is x3, y3. The last coordinate was x4, y4. But again, we repeat the first coordinate, that is x1, y1. So when you do like this, then you have the area of a triangle. So my dear student, let us see the review question of how to find the area of a rectangle. And here we have the question. The question says, find the area formed by joining the points A, 3,2, we have B, 3, -5, then we have C, -1, -5, and D, -1, 2 on the 2-dimension plane. So that is our question. So we have 4 coordinates. That is coordinate A, that is 3,2, followed by B, that is 3, -5, followed by C, -1, -5, and D, that is -1, 2. Those are the coordinates we have. So of course you can label these coordinates to avoid confusion. So here we have x1, y1, we have x2, y2, we have x3, y3, and we have x4 and y4. So our general formula for finding the area of a rectangle is given by area is equal to a half determinant of, that is x1, y1, x2, y2, x3, y3, x4, y4, and remember we repeat the first coordinate, that is x1, y1. So again, let us use arrows and dotted arrows. We are going to start with x1 and y2, then followed by x2 and y3, followed by x3, y4, then x4, y1. Then using the dotted arrows, y1 will be with x2, then y2 with x3, y3 and x4 and the y4 will be with the x1. Now, in this case, the area of a rectangle will be equals to a half. Remember, we use bracket to avoid confusion. So starting with the x1 and the y2, that is x1. Then we have y2. This one plus, we have x2 and the y3. So x2, y3 plus, the next is x3, y4. That is x3, y4. Then we have x4 and the y1. That is x4, y1. So here we just subtract the dotted arrows. This time we subtract the dotted arrows. That is y1 and the x2. That is y1, x2 plus. Then we have y2, x3. That is y2, x3 followed by y3, x4. We have y3, x4. And the last one will be y4, x1. That is y4, x1. So, my dear students, let us go back to our question. We have already mentioned the coordinates. It's just a matter of substituting these coordinates in our formula. So area will be equals to that is a half. The determinant of, we have 3 and 2, that is 3 and 2, followed by 3 and negative 5. We have 3, negative 5. Then we have negative 1, negative 5. Negative 1, negative 5. And then negative 1 and 2. That is negative 1 and 2. But remember, we repeat the first coordinate, that is 3 and 2. So here first the 3 and 2. So again, remember we are using arrows and dotted arrows to separate our coordinates. So 3 will go with negative 5, followed by, we have 3 again and negative 5. Then we have negative 1 and 2. Then negative 1 again and 2. That is for the case of arrows. For the case of dotted arrows, we are going to have 2 with 3. Then negative 5 with negative 1. Then we have negative 5 with negative 1. And the last one will be 2 with 3. So, my dear students, starting with the arrows, area will be equals to a half bracket of, that is 3 times negative 5 plus, we have 3 again, negative 5 plus, this time we have negative 1 and 2 Then we have -1 and 2. That is -1 times 2. So this one we minus the dotted arrows. So the dotted arrows here we have 2 and 3. Plus we have -5, -1. Then we have -5 and -1 again. And the last one is 2 times 3. That is 2 times 3. So area of a rectangle will be equals to a half bracket of, we have 3 times -5, that is -15. Again, we have -15 and -2, that is -1 times 2. Again, we have -2. This one minus, we have 2 times 3, that is 6. Then we have -5, -1, that is 5. Then again, -1, -5, -1, that is +5. Then plus 6. In this case, we are going to have the following result. That is area is equal to a half bracket of, we have -15, that is -30. -2, it will be -34. So that is -34. Minus, so here we have 6 plus 5, that is 11, plus 5, that is 16, then plus 6, that is 22. We are going to have 22. So this is equal to a half. So we have -34 minus 22. We are going to have -56. But remember, we use the absolute value to avoid the negative. So this one is equal to 56 over 2, which is equal to 28. We are looking for the area of a rectangle. So this is squared units. Therefore, the area will be equal to 28 squared unit. My dear student, that is the end of presentation. We've seen how to find the perpendicular distance by using the distance formula. But again, the area of a triangle and a rectangle. Till next time, don't miss this lesson of advanced mathematics. Thank you.